All right. Success, I hope. I hope you can hear me. Let me make sure I'm actually broadcasting sound according to this thing. 1, 2, miss a few, 90. Yes. All right, good enough. So, for watching now. So let's hope this is going. All right, it's a nice delay. I'll live. All right. So, sorry for the brief delay there. I just got a delivery, and I'm not going to say who from or what it is, but if you're watching, you know what it is. It's from someone on the forums. All right. This is for PCB design for Model F and Beamspring. I brought this up as a frame because people keep asking about whether it's possible to actually make your own. The answer is yes. I did this many years ago. I'm sure playing a video and then recording the video isn't going to work. So what I'll do is I'll do it. And then what I'll do is I'll edit it in later. So it's actually thing, but it's actually linked here on the channel. It's visible, but basically it is exactly what you think it is. It's a working spring. Now, not the flipper. So as you can see from the flipper, what happens is when you press the button, the spring collapses and then it slams down in one motion. And that is the actual mechanism by which the key actually activates. So let's actually talk about that for a second. Let me give you a little bit of theory of operation. All right, where's my pen? There's my pen. All right, so there is on the PCB. So if this is the PCB, it's a very thin PCB. So I'm just going to draw myself a PCB. This is looking at it from the side, and then I'll also show you. It looking from the top. So let's start at the side. There are 2 pads on the top, which, if you can imagine, look like this. And then there's another pad underneath that looks like that. Looking at it from the top, what you have is a pad here, another pad here, and then I'm going to change the color. I'm going to change the color right here and do another pad, so you can see this pad is actually underneath. There's another pad which is almost identical, which is underneath. And then what you do is when you actually do the connectivity, you connect one here and one here, which of course would be here, and then, you know, on the underneath on the red side, right? Oh, I hear my voice in the background. Hang on, let me get rid of that. All right. So if you think about it in a circuit sense, what you actually have here is two capacitors. You have a capacitor which lives here and a capacitor that lives here, and those capacitors are in series, right? So, and what happens is, if you can imagine, when you're actually building the actual switch itself, so you know, if this is, again, so I'm just redrawing this up here. When you've actually got the hammer coming down, and if this is the hammer coming down, this hammer, when it comes down, it changes the value of this first capacitor, and changing the value of that capacitor is actually what our circuit then senses. That's the theory of operation for a capacitive keyboard, effectively. All right, so let's get started. I can hide this. The software I'm going to be using today is called Diptrace. It's in the video description, a URL to download it, should you wish to download it. You're probably not going to be able to follow on live because I'm going to go relatively quickly because I want to try and get this done in an hour. And if you have any questions, of course, you can hit the forum. And I'll go ahead and answer them. I'm sure someone will put them in the wiki and all that other good stuff. Because community, yay! All right, so... the other thing you will need is on my GitHub page. That is the actual libraries themselves. So github.com. There we go. And so here in this particular GitHub library, I've got both the libraries you need to actually, you know, go ahead and do this. And I've also got some examples. So let me go ahead and pull up an example so you can see that first. So if I open up the PCB layout software, And I'll just go ahead and open up one of the recent ones. So for example, one of the things I was playing around with at one point was a Model F plank keyboard. So that's actually there right now too. Another one I played with recently was a left split Model F, because, well, why not? And also in there you can also find an example 40% Model F there too, you know, for those that are into the whole small keyboard things. But anyway, this is to give you an idea of the costs that can be incurred. This is for the Beamspring for the data center one, or the data station, I should say, that JP and myself have modules for. He actually has the whole Beam desk. I just have the module. This is to give you an idea of cost. This is basically what it costs. So it was $80 to fabricate, $21 to ship. So that gives you an idea, rough idea of what a cost can be for a 2-layer board. And at quantity 5, they get really expensive. PCBs get expensive once you get above a certain size. If you're in the 200 millimeters, 100, 150 millimeters in each direction, then it can be really inexpensive. But the moment you start going above 200 or 300, things get a little stupid, because at that point you could potentially be taking up a whole panel yourself, and there's a lot of waste. All right, so let's get rid of that. And I think you've seen this before. So this is basically the Gerber of what that looks like. So we can talk about that a bit as well. All right, so what are we going to do today? What should we play with? What should we design? This is probably a little too complicated, although tempting though it is. I'm not going to get done in 40 minutes. So let's go ahead and pick something small. I guess we could do the plank. I mean, it's very simple. Yeah, let's do that. Yeah, well, what I showed you before wasn't the plank, I just called it that. But this is a very simple one. It is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It's basically a 12 by 1, 2, 3, 4. So a 12 by 4 matrix. So that really is quite simple. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All right, 12. Cool. All right, so let's do it. So as I was saying before, in the thing that you download earlier on, I actually have done these before. So let's have a look here. So this here is what I refer to as F-tastic A, which is my model for Model F. And then we also have F-tastic B, which is basically just the mirror image of it. Bink, bink, bink. We then also have Beam A and Beam B. I don't know if you can see the difference, but basically the F is slightly taller. Of course, the reason that the F is slightly taller is because the actual PCB in the F is curved, and on the Beamspring it is flat. So it's a tiny bit of a difference. So for example, on the Beam, it is 0.75 of an inch in one direction, 0.75 of an inch in another. On the F, give me a second and I will measure it. Actually, I'm not going to do it that way. I'm going to do it using dimensions. Ding. So if I measure from here to here, oh wait, wrong one. Try that again. From there to there. See, it's 0.75 in that direction, and it is 0.8 in that direction. So you see, it isn't much, but when you see how I place them, you'll see why it matters. And specifically, so this reason I specifically have sized them this way is because I am lazy, and lazy is good. So I'm not making my changes, and I'm going to go ahead and I'm going to start a new PCB layout. All right. So here are my user patterns. I'm going to pick Model F, and I'm just going to go ahead and do it this way. All right, so we said 12 by 4, right? So a pattern is basically So it is possible, and if you were actually putting a circuit on this PCB as well, so for example, if you were to include DMA's common sense circuitry on the same PCB, then you would actually be designing this in schematic mode, but I don't have time to do that right now in 35 minutes. So I'm just going to go ahead and do just the footprint for the actual Model F, or at least a proportion of it. I can show the other another time, but it's going to be way too long, so maybe a part 2. So I'm approaching this specifically and only in the pattern mode. So I'm basically just drawing on a raw PCB. So here's the important thing. So here's the important thing to note. Whoops. Here's the important thing to note. So let's talk about layers on a PCB for those of you who may not be completely familiar with how PCBs work. There is a copper layer. Hang on, I need to... what's 0.75 plus 0.75? It's 1.5, isn't it? I'm just going to hate this. All right. So I'm going to go ahead and lay one down here. And so this is an F-tastic pad. And then I'm just going to basically shtoink one right next to it. And then shtoink another one right next to it. And 4. Now, these the green part, which I'm referring to, this is actually solder mask. So solder mask is basically the drawing that you have on the PCB, the writing. So it's not copper, it's just the writing. And that's really useful. And the reason I say that I'm lazy is because effectively what I've done here with this is I've made it so that solder mask is the exact size, which makes the distance between the pads correct. So what I've done is, in order to actually line the keys up, all I have to do is make sure that those align like that, and that's all I'm going to do. So we said 12 by 4, right? So like I said, laziness is a virtue. Copy. Paste. Make sure that's good. All right, so that should be 8, right? Okay, marvelous. 9, 10, 11, 12, so 4 more. Oops. Make sure the lines. All right, so that's 12 in a row. And then we'll do make sure they align. Yep. And then do it again and again. Just copy, paste. I'm just selecting them. Oops, didn't want to do that. All I'm doing is copying, Control C, as you'd expect, Control V to paste. By the way, Diptrace will run on Linux in Wine, and that's how I normally run it. The only reason I'm doing it on the Windows machine is because I wanted to use the tablet so I could sketch if I needed to. All right, so that's it. Let's have a quick look at our web. Yep, so I'm going to do that. So this spacebar, in theory, if this was a model, if this was a Model F and this was just a 2-space key, you would still put a barrel there because you'd need that for the stabilizer. Or the optional stabilizer, I should say. I think. Now I'm wondering if that's right. I need to find a Model F. Hang on. Where's my 2-piece? Am I enter a 2-piece? Yeah, it takes 2 barrels. All right. Although now I'm paranoid. I guess it doesn't matter since this is just a demo, right? I'm not sending this off for production, but I'm going to check just because I'm paranoid. Hang on. That's a 2.75. It's not that. All right, I'm just going to assume it is just for now, and if I'm wrong, we can correct that later. Or someone can laugh at me in the comments. It's fine. All right. So we are 12 by 4, and that's it. So we have a top side in Diptrace, and we have a bottom side. So top side is this, and bottom side is that. So I'm pressing T to switch to the top side, and B to switch to the bottom side. That's it. That's simple. Now, one of the things I did is I did a, here's one I prepared earlier kind of thing. If I go over here. And this actually shows what this kind of circuit looks like. So let's talk through this. So you can see what I've done is instead of actually putting the controller on the board itself, I like to just have a 0.1 inch header off the top and do it that way. I stick ground on the left and ground on the right and ground that separates them. So in our example here, what I'm going to have is I'm going to have 2, 4, 6. I'm going to have 6 pins for ground. I'm going to hold 6 fingers up so I don't forget. And then I'll have 12 for the columns, and I'll have 4 for the rows. So it's going to be 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. So I need 22 pins. So I'm going to need to find a 22 pin header as well. And that I can find in here. And I do connection headers. And I'm looking for 1 by 12, 2.4. I'm just gonna plonk it here for now, just so I know where it is. Oh wait, I didn't say 12, did I? I said 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22. Sorry. So I'm just gonna go ahead and delete this again. One moment. 22. All right. So let's go ahead and draw the outline of the board while we're here. So the outline of the board is up here somewhere. There it is. So all I'm doing is really just kind of sort of drawing around it. And the reason for that is because I'm going to cheat. So I'm going to go ahead and measure how big I want my border. So I'm going to want it to be approximately this length. Say make that the diagonal. And then if you look at the bottom, if you look at the pop-up that comes up, or the bottom right, you can see it tells me that it is 235 millimeters wide. Oh wait, sorry, that's the, sorry, it's on the left-hand side. It's 240 wide and 88 tall. So 240, I'm going to say 240, 85. So 240, 85, 240, 85, 240, 85. I'm just going to right-click on this, 240, 85. And I'm going to create a round rectboard, and I'm going to say 240 wide and 85 tall. We're just going to make this to start with. We'll give it a 3 millimeter radius on the outside, and then we'll drag that down, and that should approximately fit. Yay! Okay. Actually, let's make it a little bigger than 85. Let's make it 240 by 95. Actually, you might as well make it 250 by 100 because they all pretty much round up anyway. Round rect board, 5 millimeters on the outside. Nah, 3. There we go. By the way, if anyone has any questions, then feel free to ask. Let me see. I have a question already. The question is, I'm glad you dig the buckling spring. That one was actually a casting, not a 3D print, but I do have 3D printed ones too. So when this is made, is it going to be bare copper on the pads, or am I going to use a solder mask? Well, the answer to that question is it depends entirely on the model. And I don't remember. So what we can do is we can look. So if we go here and we go to pattern editor, we can go ahead and look at the various layers here. I think, so if you look at, there's top silk, actually the even easier way of doing it is to look at it here. So if you go to preview, you can actually look at each of the layers in turn. So let's see. So this is currently looking at the bottom. So if we look at the top and show all layers, objects, and then we can just go ahead and remove everything. Solder mask. So I apparently have the entire thing masked. I didn't realize that. Cool. All right, moving on. So there's no exposed copper on this is the answer to that question. All right, so back to the thing here. So if you go back to our little diagram here, what we need to do is we need to join one. We need to pick one, you know, either the top or the bottom, but we're going to stick the rows on top just because. And then we need to go ahead and join them all together. So we'll have rows on the top and cols on the bottom. All right, cool. Oh, here's what I prepared earlier. All right, we can ignore that and ignore that. All right, so back to the top layer. And remember, we absolutely need to make sure we do not connect it to this one, because that one, sorry, not that one, this one here, this one on the left, because that is the center, that's basically the center of the two capacitors. So never connect this. It should always be the one that's by itself. So it's going to be this one. All right, so we are here. We need to go into routing mode, and then we go ahead and start joining them together. Now, here's the question when we do this. How thick should this wire be? Well, that's a really good question. So I want it to be thinner than this, and the reason that I want it to be thinner than this is because if you go back, actually not you, actually it's the other side that needs to be thin. You could leave this one thick, it doesn't hugely matter. I'm just gonna leave it like this actually, but you can change it all in one go if you need to. Okay, so I'm just gonna go ahead. I want it to be neater than that. I'm just gonna go ahead and start. I'm just gonna make sure I get the right size again because I'm paranoid. See, bottom. So it needs to be this one. All right, so I go from here. I'm gonna go here. I'm going to route it all the way across to here, and if you remember I said I'm going to go ahead and route it to there. All right, and then I'm just going to join these up. Nope, I want it to be more centered than that because yeah, so a lot of PCB design honestly is just doing the exact same thing over and over again, especially this kind of thing, because all I'm doing is creating a matrix. So I'm probably not going to do this with all of this. Maybe I should just wire up one of each or two of each just to demonstrate here. See, I've already got myself in a hole here. So the problem, you see what I've done is as soon as I do the next one, how am I going to get it to the next pin, right? So it's like, I got to cross here. Well, yeah, I can cross here, but what I should probably do instead, and like I said, you're going to make mistakes like this all the time. So you can go ahead and just, there's an option down here to delete. So you can, where are you? No, delete, no, there we go. Not node. Why are you confusing me? It's been so long since I've done this. Here we go. Unroute segment. There we go. Unroute segment and unroute segment. All right, you see this blue line here? This blue line here is called a rat line. And when you're doing design, basically because the software knows in memory already that those two are meant to be connected, it's going to give you that little line there too, and basically as a nag. And there's also this thing here called DRC, which will do electrical checks and make sure you don't have any problems. And you know, if you have any problems, it should tell you. Although it won't tell me in this case because I don't have a schematic. So it's another good reason to do a schematic, I guess. All right. So what I'm going to do here is I'm going to count correctly. So this one should be the top row, second row, third row, fourth row. So this needs to be joined here to the fourth row, and hopefully it will bitch and moan at me when I try and connect it. Well, actually it won't, because it doesn't know that they're not meant to be connected yet. Oh, there we go. All right, cool. All right, I'm going to ignore the rat line for now. Okay, so now I'm going to go ahead and redo the next one. So very simple. Again, just the exact same thing. All I'm doing is, you know, pulling across here. Again, same thing. Doing this all the way over to here. And, you know, when you do PCB design, you just spend a lot of time just routing. Just making sure you get these things, you know, right. And you're going to move things from time to time, and you're going to keep rearranging things, especially when, you know, you start getting into really complicated circuits or you're doing multiprocessor stuff and all that kind of good stuff. You do end up doing a lot of jiggery pokery and juggling around, and I'm going to have to do that here. I can see that already, and that's fine. So for example, I'm going to have to move this component a little higher. There we go. It'll give me a little more room to play with. So you see those little red marks there? That's telling me that that is telling me that these pads are now too close to the edge. So I'm going to drag that away. Drag that away a little bit. There we go. All right. Cooking on gas. And then same thing again. So all the way over here. You can see what's happened down here. This is the edge of the PCB at the bottom. Again, it gives me a warning when I oh, hello work. It gives me a warning when I start to drift too far out of lane, as it were. And then the exact same thing again. I'm just going to drag over here. I'm going to route my route right over my hair, right over here. And stoink. There we go. Now, did it join those together? I think it did, so I'm going to have to separate those. You can see that it's accidentally joined those together, and the reason is because of that rat line. So I need to delete that rat line. And I'm not entirely sure how to do it. Do I just delete from... There we go. I just deleted it from the net, and then I can just go ahead and add it again here. So I can just go from here to here. What are you doing? What are you doing? Why do you think that's still netted? All right, I'm going to have to do it over here. So this is... Oops, I went a little fast here. So it thinks that these are connected here. So this is net 0, and this is... Oh, it's also going to be net 0, isn't it? What am I thinking? All right, so if I go over here, there's a net list, and I can go to net 0, and it gives me a list of all of the pins. I'm going to remove... I'm going to go ahead and remove... Why are you not letting me do... Oh, I don't have a delete key on this stupid keyboard. God, I hate 60% keyboards. Whose idea was it? Bad properties. Nope. How do I do this? How do I do this? Markings, placement. No. How do I do this? How do I get out of this without a freaking delete key? Oh, that's so frustrating. Oh, I can do it that way. All right. This is net 1. That's net 0. I can do it this way. I can do net name. I can change it from net 0 to 0, 1, 2, 3, net 3. Delete from net. There we go. Problem solved. And I need to also do the same thing here. Delete from net. Is that it? Am I good? All right, I am good now. All right. So let's go ahead and join these together. Did I mention how much I hate 60% keyboards? I figured I would. My normal keyboard's a 122, so, you know. You see, let's have a look. So when this is made, okay, that's the same question as before. Okay, so, and again, I'm just going to go ahead and route this up. And, stoink. So that should be 1, 2, 3, 4. I've just got the last one to do down here. And move this here. Again, you can see it's complaining. See the DRC, it's telling me that if I put two pads too close together, it'll complain. See, that's so cool. I love that. I love DRC. Saves my life. And there, and stoink. There we go. All right, so if we can just pretend that I've joined all of these together. I mean, strictly speaking, I could probably do it very, very quickly, but let's just pretend that I've done it because the bottom is more interesting anyway. All right, so let's play pretend. It's 5:30. All right, so I should probably save this actually. Let's save as boop. All right. So let's go to the bottom layer. Now the bottom layer, as you will see in a moment, is a little more complicated. So the reason it's more complicated is because when you are doing sensing, you are driving the rows, which means that when the rows are running, there's only one row active, and there's only one row active, but all of the columns are active. All right, makes sense so far? Good. which means you have which means since we're actually reading the columns and all of the columns are active, they are more likely to get interference, which means we have to try a lot harder to keep them electrically separated. Those of you familiar with electronics are probably aware that if you either do AC or you pulse DC, for example, like you're doing when you are strobing something in two wires that are close together, one wire will in fact induce a current in the other. So you have to try and keep those as electrically separated as you can. And so that is a lot of what you're seeing here. It's all about trying to keep them separated. So I've been asked to repeat the answer. There's going to be solder mask over the top of it. If there isn't for some reason, then what you can do is you can just alter the model, the pattern, to make sure that it's covered in solder mask. And then redo it, but it's going to be covered with solder mask because because when I made it and defined the pad, I explicitly removed the solder mask layer, so it's blank. So the entire PCB is going to be covered with solder mask, and I'll actually send a photo. I'll actually link a photo of the actual production PCB, so you can see it after I've done this video, so you can see it in the thread. So you can see what I've got to do here. Basically, I've got to do the exact same thing as I did before, except this time I'm doing columns. You get the idea. This is actually really repetitive. Nope, that's the one I prepared earlier. All right, where were we? We were here. Nope. Where were we? Nope. Where'd my PCB go? Where'd you go? No, that's not it. Oh, I closed the wrong one. That would do it. Well, I'm glad I saved it. That would have been embarrassing. What did I call it? Boop, right? Okay, it thinks that I've still got it open. Where is it? Where are you? There you are. All right. So, like I said, exactly the same thing as before, except this time we are, in fact, going to change the width of the trace because I want the trace to be thinner. I'm going to change it to 0.635 millimeters. There was a reason. I've forgotten it. 0.635. That's it. All right, and then I'm going to go ahead and just start joining these together. Again, we need to make absolutely certain, because I'm paranoid, that I'm doing the correct one. There we go. Oh, look at that. Those two still think they're connected to each other. One moment. What net do you think you're a member of? You think you're a member of net 3. You think you're a member of net 3. You're not a member of net 3. You're a member of net 0. There we go. So let's go ahead and fix that while we're here. Doink, stoink, stoink. Why are you... Well, it's electrical. It's electrically fine, so I'm going to ignore it. We can come back to that later. Let's fix that in prod. In post, I mean. All right, so I'm just going to go ahead and I'm going to go ahead and start joining these together. There we go. So exactly what you'd expect. So these are our columns, which are going to be our sense lines. By the way, if you have not availed yourself of DMA's common sense controller yet, I strongly encourage you to do so. It is that controller that actually allows us to, should we say, not be as strict with our PCBs as we used to have to be. At one point, sometimes it would take us 2 or 3 attempts to actually get a working PCB, simply because the capacitance needed to be so uniform across all of the pads. Because in the previous controllers, like the IBM controller and the X-Watts controller, there was only one single, what's the word I'm looking for? There was one single threshold that you would set to say whether something was active or not. Whereas with the common sense control, you can actually set a threshold on every different key, and that's really useful. Oh, I so want to open this box, but I can't because I don't know if it's public. So I'm going to behave. All right. So as you'd expect, again, so I've got my 2 ground here, which I use. I have 2 grounds separating those, which means this here is going to connect. So again, I'm not going to do all of them. I'm just going to go ahead and hook up some of them. And you'll see that I'm going to try my best to avoid the other one as much as I can. So I'm just going to, but like I said, you'll usually move them. There we go. Bomb. And again, same thing as before. All you're doing is this. There we go. All right. I'm going to do 2 more. And then I'm going to start talking about ground. So let me mention WCAS a moment, because he just started making his Model F keyboards using 4-layer PCBs. Now, 4-layer PCBs are a touch more expensive. That's usually an understatement. They're usually a touch more expensive. But what he's done is he has put these signal lines here on the bottom, and he has put a ground plane in the 3rd layer. Now, the interesting thing about that is that that is really, 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 really going to help when it comes to isolating signals, because now the forwards and the backwards, the columns and the rows cannot interfere with each other, because there is this huge flood of metal between the lines that actually carry those, which means he doesn't have to worry about doing what you'll see in a moment, which is basically the biggest pain in the butt there is, which is this pattern around it, which is effectively what you're trying to do is stop the board from actually, stop these columns from actually, interfering with each other. So as you might expect, again, all you've got to do is do the exact same thing. Just going to change the width again. What width do I have? Did I have it set to before? Sorry. It tells me here it was 1.27 millimeters, so I'm going to go ahead and use that because lazy. 1.27 millimeters. I'm hoping this is actually illustrating this is not as complex as people think it is. People think that this is black magic, and it isn't. Okay, admittedly, it was at one point in time. It isn't anymore. It isn't black magic anymore. All right, so all I'm going to do is draw this. Now you see if I... Oh, okay, so I'm going to... Okay, so I actually want my DRC to activate to tell me if I get too close. So I'm going to go ahead and I'm going to create... I'm going to go ahead and give this a name. I'm going to call this ground. So the reason I do that is is so that if I try and do this, it should now complain at me. See, I've got these red lines, so it's telling me if I get too close. That's awesome. All right, so what I'm going to do now is I'm going to go ahead and create this as close as I can, but not actually touching. But like I said, not perfection, because I have about 10 minutes and I want to show the entire process. And you can see what I'm doing here. Actually, I'm just going to go straight down, pretend I follow the line. Actually, I don't need to follow the line because these are vertically aligned. So there we go. So I'm just yeah, pretend this is all pretty and stuff. Again, I would probably be a lot more strict about this if I had to worry about if I was using XWatts or if I was using the original controller. I would be a lot more strict. But frankly, because I'm using common sense, I don't have to be. All right. So you guys get the idea? I mean, really, this is effectively all there is to it. You just follow this all the way around, etc., 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 etc. Pretend this goes up here and down here and up here. You see what I'm doing? Yeah, we'll just pretend for now. Etc., 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 etc. And then we come up the other side. Like so. And then straight across to this ground. Dink. Join to this ground. Marvelous. And then with this one, I'm just going to go ahead and join that here. And join that here. And we are good. All right. So let me see. What else do we have to do here? So if you can imagine, we have all of our columns hooked up and we have all of our rows hooked up. That's it pretty much. The only other thing we might want to do, and you can see maybe that I did it here, how necessary it is open to discussion. But what I did was I filled this area here with copper to cover the lines. And I did that because the original keyboards do that. Do I really need to do that? Probably not. Like I said, very reliable. But you can go ahead and do that if you want to. There's still a lot of worry that, you know, we're doing a lot of cargo cult stuff, and we're still not 100% sure what is vital and what isn't. But like I said, we don't have to be as strict anymore. All right. So, let me see here. What are we going back to? So if you can imagine that I have completed this, I'm trying to see if there's anything else that I really need to talk about. Oh, you might want drill holes. So there is a, oh, you want to set the origin too. So define the origin, which is where 0 is on your PCB. That's this one up here. And you just define origin, and then just there you go. It doesn't have to be exact because they actually do their own in the factory, but as long as your board just has to be inside of it. Hit Control S and save that. Let me see, what else do we have to do here that matters. We have, again, so this is for placing additional pads. If you want to put text on it, you can put text on it if you want to, yeah. So I'm looking for, where are you? I don't see you. Somewhere here. I must be going blind in my old age. There it is. So if you need to do mounting holes, so for example, you know, you actually want to screw this onto something, then you can just go ahead and drop your holes in, and just double click and give it the size. So there's its distance. Let's say I'm going to use an M5 screw or a 5mm screw. You just change that to 5. Aha! Look at that. See, it told me that I screwed through one of my tracks. So I can either move my track. Oh no! Look, I just screwed. See, this is what this is all about. This is all about. PCB routing is all about moving stuff around. That's all we do. We throw things on a wall and we move stuff around until all the red bits go away. That's basically how it works. All right, DRC, cool. No errors found. All right, so let's pretend this is complete. So I've routed all of the, routed all of the verticals, all the columns. I've routed all of the rows, which are the horizontal ones. So the different ones on the top, ones on the bottom. If I wanted to add the floods, I can do that too. Let's pretend that I've done all that. Does anyone have any questions or general questions before I go ahead and just switch to here's one I prepared earlier? All right, we'll assume that if it hits, it hits. Sure, I'll save the changes. All right, so let's go to here's one I prepared earlier, and I'll show you the final stages. And I'm about right at 15 minutes. All right. So open, let's do this one. All right. So here's one that I prepared earlier, TM. And it's exactly what you'd expect. Like I said before, you can actually look at a 3D rendering of it. Now, watch it crash my machine. Look at that. Looks like my my YouTube hung as well. That's not good. That does not bode well, does it? Let me hit reload, see if it gets me live. Cannot find any models. Yep, there's a reason for that. We don't have any components. There we go. There we go. Look at that. Do you see the pads? No, there's a reason for that. Let's go ahead and change the solder mask to a different color. And let's change the copper to a different color. And I think, yeah, it's because of the last thing I was doing. Yeah, so that's not going to help, is it? Let's change that to green. No, none of it's going to help me. All right. I have to show you a different way. That's fine. All right. So let's talk about how we actually get this to manufacture. So there are lots and lots and lots and lots and lots of different manufacturers. There's PCBWay, which is who I use for large PCBs. So PCBWay is, I'm not going to say by far the cheapest, but for any time you do a large board, like a keyboard, PCBWay is going to typically be $20 or $30 cheaper than everyone else. Or more. And to be honest with you, sometimes, yeah, sometimes a lot more. There are other websites that I like to use. One that I particularly like is called Elecro. They're good peeps, and I've always been very, very happy with them. So we can go ahead and show you. I mean, it's the exact same thing as you'd expect, right? So right here you can go, you know, more categories, and here they will have they'll have their services here somewhere. So we want services, PCB. We want PCB manufacturing. There we go. Yeah, we don't need premium. And then you can use this to get an idea of cost, right? So this is a 2-layer board. What did we say our dimensions were? Actually, let's calculate this one. Give you an idea of what this would give you an idea of what this one specifically would cost. So we're going to go to our little dimension tool, which is here. Measure its horizontal from stoink to stoink. That is 246 stoink to stoink. 246.97. All right. So dimensions are 246, 97. Let's do a quantity of 5, 1 design, PCB thickness. Now, so 1.6 is a standard PCB thickness. My advice to you, waggle finger, is to go thinner for that if you are going to bend it. And if you're doing a Model F that isn't completely flat, then you're going to want to bend it. So 0.6 or 0.8 is good. You can pick your color. Typically, oh, look at that. Typically the PCB colors at Elecro are free. We probably don't need gold. So this is the actual coating on the PCB, so the pads that are exposed. So when I'm doing, you know, production designs for companies that have, you know, proper circuits on, I will always use gold. Not only does it make a good impression, but honestly, it's a lot easier to solder to. And that, for the sake of a couple of dollars, I will take that every single time. No castellated holes, don't care about the copper weight. I don't need a stencil because I'm not doing any surface mount. 4 to 7 things, shipping. There we go. There we go. Perfect. So that gives you an idea of the cost here. So that's actually really, well, their price has come down significantly. Look at that. 28 bucks. Dang. 4-layer. Do you see what I mean about it being more expensive? So it goes from $28 to $92. It's a significant chunk of change difference. It also takes longer. So from 4 to 7 to 5 to 8. So Yeah, when you add layers, 6 layers, $221. 8 layers, $357. Yeah, adding layers is the most effective way of doing it. 1 and 2 are typically the same though, because it's just easier that way. So that gives you an idea of the costs, right? So very, very simple. So 28 bucks gets you 5. We did quantity 5, right? Yeah, quantity 5. If you do quantity 10, there's actually typically, there we go, 10. You want to go to 100. You know, you get the general idea, right? It's all kind of obvious. There you go. 28 bucks. $26 in shipping gets it to me personally. I get mine in 3 days, including weekends. I've actually put an order in on Thursday and had the PCB arrive on Monday morning at 10 a.m. DHL is amazing for me. But I live really close to one of their central hubs, so the rest of you, sorry. All right. So how do we see they are asking for Gerbers? So how do we give them Gerbers? Well, let's talk about that. So let's talk about what a Gerber is first. So a Gerber is basically a mechanical description of every layer. And so in order to produce those Gerbers, we go here, and when we go to export, Gerber. All right. So all of these defaults are typically good, although I will pretty much always switch to metric because, and then you choose which of the layers you want, or you can just click export all. There we go. So I'm just going to make a directory. There we go. I'm going to call it demo Gerber. Tick. And then I can just go ahead and save the files. So top assembly, top silk, top mask. I think you see how this is going. All right. So there is one other thing that you have to export, which is the drill hole files. So you go to export, and this is, where are you? NC drill. And it's the exact same thing. You want it, so top, bottom, click auto, and then click export, and that's it, done. Close. Then we go to our little, we actually go to our, whoops, and do that. I can open this. There we go. And then what I'm going to do is choose the ones that I need. So this is board outline. I love how it thinks it's a GIMP file. It's hilarious. So board outline you need, because that's, you know, what the outline of the board is. Bottom is the copper on the bottom. Bottom assembly we don't need. That's what you use to tell the manufacturer what components to place. We don't have any. They're not doing it, so we can delete that. Did I mention I miss having a delete key and I hate 60% keyboards? Delete. All right. Bottom dimension we don't care about. So delete. Bottom mask we need. Bottom paste we don't need because they're not making us a mask. Bottom silk. Through, this is what, these are the drill holes. Top assembly, so we'll delete the top assembly. Top dimension, don't need that either. Top mask we need. Top paste we don't need. Delete. And top silk. So we should have top, bottom, board outline and drill. That's it. Now you throw them into a zip file, which I don't know how to do in Windows, so I'm going to drop the bash. Makes me laugh every time. Zip-o to, this is, which supplier was I doing? It was Crow zip. And it is demo Gerber. There you go. The fastest amongst you will be able to work out what my password is from that. Still makes me laugh to think that Windows Microsoft Windows is the most widely distributed Linux distribution now. Sit and think about that for a moment. Also, it doesn't run System D, which makes me giggle a lot. All right. Oh, I probably need a... What the hell was that? All right, we need a recurse flag. There we go. Let me go here. Magic over. Oh. Ta-da! All done. That's it. You do the upload, you pay for it. Wait 3 days, 4 at the outside, and your PCBs are done. That's it. Any more questions? Try to think if there's anything else you guys might find interesting that I can talk about. Oh! This is a picture of a genuine Model F for those that have never actually opened one up. I mean, you can see it's exactly the same as before. And remember I was saying about doing the flood thing on the opposite side of the board? I'm not going to say the only reason, but the main reason that we do it is because you can see they did it. I mean, they did it. So maybe they had a good reason. I don't know. But like I said, there was an awful lot of cargo cult going around to the point where you probably can see it actually if I zoom in enough. I can't zoom in anymore. So there are these little dots, these little copper dots, which are at the top of the pads. I wonder if I can find them if I do this. IBM Model F PCB. Let me see if I can find a picture here. Yeah, this one will do. This is actually kind of funny. So no, that's not what I wanted to do. Hang on. Open view image. There we go. So can you see these copper pads here? These little copper dots. So here's the question. What are they for? When the first people on the forums, like I don't know how long ago it was, maybe 8 or 10 years ago, started trying to reverse engineer how these keyboards worked and how the controller worked. They didn't know whether these dots were functional or not. So we created them. And they were lovingly referred to as magic dots. So we actually at the time, we had no idea what they did. So we put them in. Again, this is traditional cargo cult. If you don't understand it, you copy it, right? And then, you know, the problem you have with PCB fab is that it can be, you know, days and, you know, tens or hundreds of dollars, depending, to go ahead and fabricate, you know, and do each iteration. So you want to make as few mistakes as possible because, of course, every mistake costs money. And plus, we're excited by these things, damn it. So, you know, they were lovingly referred to as magic dots. So you'll see a lot of people's custom PCBs used to have them. My best guess as to what they're for now, honestly, is if you look, they kind of align with the corners of the actual Model F barrel. So part of me wonders if they're like an alignment thing for testing jig or something. Let's go ahead and ignore that. I think that's probably it. I strongly advise you to grab Diptrace. Diptrace is awesome. It's by far my favorite thing. I actually have a full license for it that I paid for because I do large circuits, and so I do need those 4 layers and all that other good stuff that comes with it too. So if you can afford it and you're doing profitable stuff, or actually if you're doing profit stuff with it, you should buy a license because it is worth the money. Definitely worth the money. Strongly recommend. 5 thumbs up. Would watch again. Any final questions? YouTube keeps freezing on me. It's not a good sign. Let me check the chat one more time. Anyone ask any additional questions? Nope, no additional questions. Alrighty then. It is 6 p.m. Thank you all for watching. Peace out.